Welcome to the course MCDM Techniques using R. So, in previous few lecture we completed our discussion on topsis. So, in today's lecture we are going to start our discussion on another technique that is called VIKOR. This technique is also quite similar to topsis in terms of procedure. So, let us start our discussion. So, what VIKOR stands for, as you can see in the slide. Then the main idea behind VIKOR is quite similar to what we discussed in topsis. Both VIKOR and topsis they are also classified as compromise ranking method. In previous lecture on topsis we talked about that topsis is also categorized under distance based method or reference based approaches. VIKOR can also be classified similarly under the distance based method and reference based approach. Also compromise ranking VIKOR is also classified as compromise ranking method. So, what do we mean by this? So, compromise solution is a feasible solution which is closest to the ideal. So, just like in in topsis we were looking for a solution which were which were having shortest distance from the ideal point and farthest away from the anti-ideal point. Similarly, in VIKOR also we are looking for a solution which is closest to the ideal point. So, the compromise word, that is term that is being used here for these two techniques. So, it also essentially means a similar thing, that compromise solution is a feasible solution which is closest to the ideal. And what do we mean by a compromise here? Then an agreement established by mutual concessions. So, that is the additional part in VIKOR. So, VIKOR typically it is used for multi criteria optimization of complex systems. So, what we once we do our VIKOR modeling, so the kind of output that we get is the compromise ranking list, the compromise solution and the weight stability intervals for preference stability of the compromise solutions obtained with the given weight. So, this is more like doing a sensitivity analysis of the solution with respect to weights. So, if you make certain changes, certain delta changes into your criteria weights, so how the results, how the compromise ranking list or the compromise solution is going to be going to change. So, that is also can be easily determined in VIKOR. So, weight stability, by weight stability intervals what we mean is the range of criteria weights where a particular compromise ranking list or compromise solution is going to remain same. So, within that range a particular solution, a particular ranking list is valid. So, if you make your if you change the criteria weight slightly outside of that particular range, then the the list and the solution might change. So, that is what it means by in the third point, that weight stability intervals. So, we also obtain in VIKOR, which is actually indicating the preference stability of the compromise solution obtained with the given weights. Introduces the multi criteria ranking index. So, just like in topsis also we get a rating index, here also the similar thing. So, based on a particular measure of closeness to the ideal solution. So, there also in topsis when we discussed, there also we had developed we have discussed a closeness ratio which was used to finally determine the closeness from the ideal and anti-ideal points. Similarly, here we are going to discuss a particular measure which is to be used to determine the closeness to the ideal solution. Let us move forward. So, the measure that we just talked about, so how this particular measure is formulated. So, we are going to discuss that aspect now. So, this multi criteria measure for VIKOR and for compromise ranking that we obtain in VIKOR is developed from LP metric. The same metric is also used in developing the metric for topsis, but in this particular lecture we are going to discuss this in more detail. So, there we did not refer to LP metric aspect in Tops's lecture, but here VIKOR it becomes more important. So, the multi-criteria measure for ranking in VIKOR that we use is based on LP metric. So, this is typically used in as an aggregating function in another method referred as compromise programming method. So, this metric has been taken from there. So, how this particular metric is defined you can see in the slide. So, LPK where P is a parameter ranging between 1 to infinite, and the expression you can see that within the curly braces power of 1 divided by P, and inside of it we have the summation ranging from j is equal to 1 to m, where j is for criteria. So, the number of criteria that we have is m criteria. So, we have total number of m criteria. So, the summation is ranging from 1 to m, and then within the brackets what we have the power is p, again the parameter p, and within this bracket what we have is kind of a weighted sum of something. So, weighted sum of a ratio. So, this Wj is actually standing for the criteria weight, where j as I said is indicating the criteria, and then we have this this ratio expression here where this is Fj star minus Fkj, where k is actually standing for the alternative. So, alternative we are considering that there are n alternatives. So, k is ranging from 1 to n. So, this ratio is Fj star minus Fkj divided by Fj star minus Fj minus in superscript. So, we look at this expression, this looks like a min max kind of normalization if you really look at it, and then weight is also there. So, therefore, it looks like a weighted normalization of min max kind of formulation. So, that is being used, this kind of formulation is being used to define what we call as LP metric. So, in VIKOR values of this parameter p, two specific values are taken. Therefore, two specific forms of this LP matrix LP metric is actually are taken for VIKOR. So, we will talk about those two forms. So, as I said that in the previous this expression that we talked about, k stands for n alternatives, so 1 to n, and the j stands for m criteria, as you can see here. Here you can see j, the summation is over j 1 to m, and this is for the alternative, right. So, you can see alternative k 1 to n and criteria j 1 to m. And as I said Fkj, this is the rating score. So, just like in Topsys we talked about that we got to have the performance table, the performance scores of our of various alternative with respect to different criteria. Similarly, here also we are supposed to have these scores where Fkj is denoting the rating score of kth alternative with respect to jth criterion. So, we go back to the previous mathematical expression we are talking about here. So, this ratio overall this ratio expression that we have in this this is the Fkj. So, that is what I meant by min max kind of normalization. So, here asterisk is best and minus is worst rating score with respect to the criterion j. So, if you go back to the previous expression, it looks like max minus the value divided by max minus min. So, that is why when I said that it looks like max min kind of normalization, and then Wj is the weight of the criterion j. So, this is about the LP metric that is actually used to determine the measure in VIKOR. Now, what parameters, so what values of parameter p is actually taken for the VIKOR method. So, L1k, so p is equal to 1 and L infinite k. so P being the infinite. So, these are actually used as boundary measures to formulate the ranking measure. So, here you can see L1k is also denoted by Sk, and L infinite k is also denoted by Rk. So, these these two measures Sk and Rk will become important part of the VIKOR steps that we are going to talk about. So, both these when we take the values of 1 and infinite to define these two measures, you can see how the expressions are going to be. So, Sk will be something like this. So, if you go back to the LP metric formulation, you can see 1 by P and P here. So, when you take the value of P1 or and in the infinite, so the expression will actually change. So, this is what we get. So, Sk is now summation over the criteria, and this is the expression Wj weights of criteria, and then multiplied by this expression of Fj star minus Fkj divided by Fj star minus Fj minus in superscript. So, this is Sk. So, here we are taking summation. So, here if you notice that Sk where k is standing for alternative. So, this is standing for alternative. So, for every for all the alternatives we are going to compute this sum, as we will discuss in the steps of VIKOR. So, this is for the criteria. So, as we have as I have mentioned before as well. So, you can see this is the weighted normalized score kind of expression, and summation summed over criteria. So, this weighted sum is actually being taken for all the alternatives individually. So, this is what we have the measure as Sk. Then we have Rk. So, here if you see the same expression, this weighted score, then we are just trying to compute the maximum value. So, which is for with respect to j. So, out of all the criteria that we might have, so we are going to find out the maximum value, and that is going to be defined as the another measure, that is Rk. Let me take you back to the LP metric expression. So, one important aspect of this is what this expression is actually representing. So, here you can at the the last line of this slide, you can see this, that this LP metric is actually representing the distance of alternative Ak to the ideal solution, right. So, so this is the whole formulation is in a way a kind of distance metric. So, that is when I said at the start of this lecture that even VIKOR is also categorized as classified as a distance based method. So, here the metric LP metric that we are using is also a kind of representation of a distance of an alternative k Ak to the ideal solution. So, now the same representation is being used here also for Sk and Rk also. So, let us move forward. So, if we obtain a VIKOR solution using min k Sk, that means all the S values for different alternatives will be determined and find the minimum of minimum S value, then that would actually indicate maximum group utility majority rule. So, what do we mean by this? This in a sense, if you go back to the expression, this is a summation over criteria, right. So, this is like summation of weighted scores. So, when we take the minimum value, so it is like common denominator, the common out of all the criteria that are there. So, that value is being taken. So, this is the maximum, this is in a way indicating a kind of a rule, majority rule, and the maximum it is indicating the maximum group utility, right. So, we take the minimum of Sk. So, at least that much of group utility is going to be represented by this particular solution. So, as I said previously that the measure that we are going to use in VIKOR is actually based on these Sk and Rk as boundary measures, right. So, the actual measure that we are going to use in VIKOR for ranking is we will discuss later, but these SK and RK will actually serve as a boundary condition for that measure, as a boundary measures, right. So, here when we say that we are trying to SK min K, SK is actually indicating the maximum group utility, the utility which is minimum in a sense, because this min value is being taken. So, this is the best representation of the group utility that is going to be shared across all scenarios. So, this will become a kind of boundary measure in overall VIKOR implementation. Then solution obtained by min K R K, here this indicates minimum individual regret of an opponent. So, if you go back to what how the RK was formalized. So, here we are taking the maximum value of this weighted score, right, and again out of all the values that we have for alternatives. So, we take the minimum of them. So, that is actually indicating in a way minimum individual regret of an opponent. So, so this is also in a way indicating a boundary condition. So, these are like a boundary measures. So, indicating some boundary conditions or boundary measures, which overall how this is to be used in the final measure, we will see that in this lecture. So, these are two scenarios, the SK and RK that we talked about, and how they are going to be incorporated in the in the particular measure that we are going to use in VIKOR. So, we take min K of SK and the min K of RK, and these are used as boundary measures. So, we would actually in the final measure QK that we are going to talk about in the coming slides, this is actually going to be a taking a balance between these two. That means maximum group utility and minimum individual regret. So, we are going to discuss a formulation, a particular expression that is going to take a balance between these two boundary measures, and that particular measure is going to be finally used for producing the obtaining the ranking through VIKOR. Now, at this point let us also talk about the compromise solution FC. So, what do we mean by compromise solution FC? So, we have already talked about what we mean by compromise solution. So, we are here indicating it using capital FC. So, this is a feasible solution that is closest to the ideal solution F asterisk. So, let us understand this through a graphic here. So, just like in TOPSIS, we there also we talked about a particular number of alternatives, and we talked about ideal and anti-ideal points, and we were looking for shortest distance from ideal point and the farthest distance from the anti-ideal point for a particular alternative to be the best alternative. So, here also a similar kind of graphic we can see here. So, here you can see that this is our ideal point. So, one difference that you can notice by now that is there in VIKOR in comparison to TOPSIS is that we are just comparing with the ideal point. So, there is no anti-ideal point in case of VIKOR. So, this is our ideal point, so that we talked about, and this is our compromise solution. So, these are two criteria. One is F1 along y axis, then other one is F2 along x axis, and you can see here. So, these are probably the best values. So, if we take a curve here, so along these two criteria, this FC is somewhere here. So, this is in a way representing the feasible solution which is closest to the ideal, right. So, this in a way also gives us the feasible set here, and the other part become the non-inferior set, right. So, so out of all the points which are part of this line, so they would become non-inferior set, and this would be our feasible solution. And we are feasible solution, as we talked about, it should have the shortest distance from the ideal point. So, this is what we do actually in VIKOR modeling. So, let us talk about this in more detail. So, now what we are going to do is we will discuss the steps of VIKOR, and whatever we have discussed till now about different metrics like S and R, we will talk about them, and then we will also discuss the final metric QK, that is actually used for producing the ranking. So, VIKOR steps, first one is that determine best and worst F values for all criteria function. So, why this is the first step? Because if you go back and understand this SK and RK mathematical expression here. So, you can see F star j here, and you can also see Fj minus. So, Fj asterisk and Fj minus. So, these two values are going to be used for computation of Sk and Rk value for all the alternatives. So, it is better that we do this computation first. So, best and worst F value. So, best indicating the F star and worst indicating the F minus values. So, if we for all criteria, if we compute these two values, only then we can move ahead, because the Sk values and Rk values are actually with respect to alternatives. So, first step we need to compute these values. Now, how this is to be done, how we are going to determine what is best and worst for a particular criteria. So, if a criteria function represents a benefit, so just like in previous techniques that we have discussed in this particular course, whenever we talk about the preference direction of criteria. So, whenever the criteria is to be maximized, whenever the criteria is a function which represents a benefit. So, we need to maximize across alternatives to obtain best value and minimize to obtain worst value. However, if the criteria function, this preference direction for criteria function is actually cost, right, then the situation will change in terms of determining the best and worst F values. So, there we will have to do the reverse, because this is a cost function. So, therefore, we would like to minimize the value for best score. So, the best F value would be here obtained through minimization. So, we will minimize, and the worst values would actually be through maximize. So, if the cost is on the higher side, so that would be representing a worst scenario, and if the cost is on the lower side, so that would be representing the best scenario. So, this is what we mean. So, depending on whether the criteria is benefit or cost, we would be doing it accordingly. Now, let us talk about the next step. So, once we have these best and worst F values, where F asterisk or F minus, once these have been computed as part of the first step, then we can go ahead and plug in these values in the expression that we saw for Sk and Rk. So, we are going to compute the values Sk and Rk for all the alternatives. So, here k is standing for alternative, as we talked about. So, for all the alternatives we would be computing these values. Once this is done, once we have these values, then now we are going to talk about in the next step our measure QK. So, this is the measure that is actually used to produce or obtain the ranking in VIKOR. So, if you look at this particular measure here, so this measure is to be computed for all the alternatives just like Sk and Rk. Here if you look at this measure, so we have introduced a new parameter here, that this is V. So, and here we have 1 minus V. So, what is this V? V is the weight of the strategy of majority of the criteria. So, this V can be typically it is representing the the weight of the strategy, and this strategy can be there could be different scenario for this strategy. So, the weight can be accordingly set. However, the default values, that is value that is typically taken is 0.5. So, that is actually indicates a scenario of consensus. So, something that is being obtained through consensus. So, right. So, if you see these two expression of QK which have been summed, so they also look like a weighted scores here. So, V and 1 minus V are representing weights in a sense, and then we have two ratio expression here. If you look at the ratio expression, one is Sk minus S asterisk, which is the which is defined like this. S asterisk is minimum of min k Sk. So, when we talked about previously the solution, we talked about min k Sk, and we talked about min k Rk. So, they are representing the best solution here. So, these values are to be plugged in here in this expression, and again we will get a score for Qk. So, you can see when we talked about that Sk and Rk are kind of boundary measures, and to be used later on for the metric that we are going to use to produce the ranking. So, which is Qk. So, here you can see Sk and Rk are being used. So, we are trying to balance between the utility and the two particular aspect that we talked about. We are trying to balance here maximum group utility versus this maximum group utility versus minimum individual regret. So, this is exactly is being represented in this expression, right. So, through this weight which is in a way determining the relative importance of maximum group utility and minimum individual regret, we are trying to balance this out and trying to produce a metric here. Now, if these values so we can take min values, or otherwise we can take S asterisk as 0 and R asterisk as 0. S minus is the opposite of this, because this is representing the worst scenario. So, max here max k x Sk, and then similarly R minus is also representing the worst scenario here, max k Rk value is to be taken. So, this is about the metric Qk. Now, once we have computed the values for all the alternatives for these three metrics S, R and Q, then we are in the next step. What we are going to do is we can sort the alternatives by these values S, R and Q. So, what we will get is 3 ranking list. So, at the end of this particular step we will get 3 ranking list, and using these 3 ranking list we are finally going to determine our compromise solution. So, this therefore, then once this computation part has been completed and we have got the values for S, R and Q for all the alternatives, then next step becomes more important in terms of what are the rules that we follow to determine a compromise solution or compromise ranking list. So, in the next few steps we are going to actually talk about this. So, now the next step is about proposing a compromise solution, that is alternative A dash. So, this is something that we are going to propose. So, what steps we follow? So, this alternative A dash is actually ranked best using measure Q, and how do we determine what is the best using measure Q? So, one with the minimum value Q. So, as we talked about in the previous steps, for all the alternatives we will be sorting them, we will get 3 ranking lists by sorting S, R and Q values, and therefore, it will be easy to spot the values for S, R and Q having the alternatives having the minimum value. So, for first we will focus on the list that is being produced using Q. So, we will look on that list, and the alternative which is having the minimum Q value, that can be considered, that is going to be first considered as the compromise solution ranked best, right. However, 2 conditions are to be satisfied, C1 and C2. So, these are the 2 conditions that should be satisfied before this particular alternative having the minimum value in the Q list is actually can be ranked best. So, what are these two conditions C1 and C2? So, to propose a compromise solution alternative A dash, first condition C1, that is if Q A A double dash. So, this double dash A double dash is actually the second ranked alternative, A dash is the first ranked alternatives, and I have already told you that it is based on the minimum Q value. So, the alternative with minimum Q value would be A dash, and the alternative with the second second best second best minimum value is going to be A double dash. So, once we have identified A dash and A double dash, we can check for this expression. If Q A double dash minus Q A dash is greater than or equal to D Q, where D Q is this value 1 divided by n minus 1, where n is the number of alternatives. So, this particular difference is being checked, so that there is an acceptable difference, between the best alternative and the second best alternative. So, only then best alternatives should be accepted as the best in the list. If the difference between first and second ranked alternatives, it is quite close, then probably our acceptability of considering the first ranked alternative as best might not be that higher. So, therefore, that is being checked through this mechanism, where if Q A double dash minus Q A dash, this is going to be, if this is greater than or equal to D Q, where D Q is 1 divided by n minus 1. So, this is the condition, this is the first condition that should be met before we can say that alternative A dash is actually the best alternative. So, then there is this condition 2, this should also be satisfied. So, so at this point we would like to stop here in this lecture, and in the next lecture we will continue our discussion on this part. We will talk about what the condition C2 is and what happens if one of these condition is not satisfied, then how do we determine the compromise solution. So, we will discuss all this in the next lecture. Thank you.